How is air density related to air pressure?
The expression thin air is actually a reference to the atmosphere's density, or how thick the air molecules are near the Earth's surface. In chemistry terms, density is merely the mass of anything, including air, divided by the volume the mass occupies. For example, the density of dry air at sea level is high, mainly due to the pull of gravity. In metric system terms, sea level density is about 1.2929 kg/m3, or about 1/800 th the density of water. But as altitude increases, the density drops dramatically. Mathematically speaking, the density of air is proportional to the air pressure and inversely proportional to temperature. Thus, the higher up one is in the atmosphere, the lower the air pressure and the lower the air density. There is somewhat of an athletic advantage to higher elevations, at least for players of such sports as football and baseball. Because the air density is lower, a ball thrown in high elevation places like Denver, Colorado, will travel even farther than a ball thrown in a close to sea level city, such as Miami, Florida. In fact, the air at the Denver Stadium allows balls to travel almost 10% farther.
What are some well-known axiomatic systems?
One of the most well-known axiomatic systems was developed by the Greek mathematician Euclid, c. 325 c. 270 BCE. He presented 13 books of geometry and other mathematics titled Elements, or stoicheion in Greek. Included in these books were theorems about geometry and numbers derived from 5 postulates about points, lines, circles, and angles, 4 axioms about equality, and 1 axiom stating the whole is greater than the part. A more modern axiomatic system is the axiomatic set theory, which is based on 8 axioms and 3 undefined terms.
What are some physics fields that rely heavily on mathematics?
Almost every field of physics, especially modern physics, relies heavily on mathematics. For example, mathematics is needed to understand the concepts of acceleration, velocity, and gravitational forces. Statistical mechanics also uses an intense amount of mathematics, and it is impossible to comprehend quantum mechanics without a good knowledge of mathematics. In fact, the subject of quantum field theory is one of the most mathematically rigorous and abstract areas of the physical sciences.
What is the concept of bound?
Similar to sequences, see elsewhere in this chapter, in calculus bounds are divided into the upper either greater than or equal to every other number in a set of numbers, or greater than or equal to all the partial sums of a sequence, or lower, less than or equal to every other number. The symbol for infinity, OO, is used to denote a set of numbers without bound, or that increase or decrease to infinity. In calculus, the bounds can be divided even more into greatest or least. For example, the greatest lower bounds and least upper bounds are of special interest to calculus, as those numbers may or may not be found within a set.
How do geologists measure the intensity of earthquakes?
Geologists measure the intensity of earthquakes in order to compare and judge potential damage. One of the first standard ways to measure intensity was developed in 1902 by Italian seismologist Giuseppe Mercalli, 1850 to 1914, and is called the Mercalli Intensity Scale. It was later modified and renamed the Modified Mercalli Intensity Scale. The numbers, in Roman numerals from I to 12, represent the subjective measurement of an earthquake's strength based on its effects on local populations and structures. For example, Roman numeral V on the scale represents a quake felt by nearly everyone, with some dishes and windows broken, unstable objects overturned, and disturbances of trees, poles, and other tall objects sometimes noticed. But scientists wanted a more solid, less subjective scale. One of the first scales developed to measure the true magnitude was invented by American seismologist Charles Francis Richter, 1900 to 1985, and German-born seismologist Bino Gutenberg, 1889 to 1960. In 1935 these scientists borrowed the idea of magnitude from astronomers. Stellar brightness is measured by magnitude, defining earthquake magnitude as how fast the ground moved, as measured on a particular seismograph a specific distance from the quake's epicenter. The Richter scale is not a physical scale like a ruler, but rather a mathematical construct. It is not linear, but logarithmic. Thus, an increase in each whole number on the scale represents a tenfold increase in power. Its numbers represent the maximum amplitude of seismic waves that occur 62 miles, 100 kilometers, from the epicenter of an earthquake. Because seismographs are usually not located at this exact interval, the magnitudes are deduced using the arrival of specific waves of energy given off when an earthquake occurs.
What is the definite integral?
In actuality, the area is actually determined using limits. In the function f, x, as n gets larger, the numbers determined by left n, and right n, will get closer and closer to the area n.
What are card games?
A collection of cards, or a deck, is a set of n rectangular pieces, usually made of heavy coated paper or cardboard, that holds special varying markings on one side and a uniform, identical pattern on the other. The special markings make each card unique, with each marking representing something playable in a certain card game. The most common cards for games is a 52-card deck represented by 4 specifically colored suits: spades and clubs in black, diamonds and hearts in red, with 13 cards of each suit numbered 1 through 10, followed by several face cards: Jack, J, Queen, Q, and King, K. Card 1 is usually an ace, card 11 is represented by a Jack, 12 by a Queen, and 13 by a King. The value of the ace often changes depending on the game. For example, it can either hold a value of 1 or 11, in blackjack, or 14, in bridge. Such cards are also used for many gambling games, such as poker and baccarat. Interestingly enough, the investigation of the probabilities of various outcomes in card games was one of the original motivations for the development of modern probability theory. For more about probability, see Applied Mathematics.
What are the arithmetic mean and geometric mean?
The average, in general, means the average value of a group of numerical observations or the statistical measure of the arithmetic mean, or just the mean. On a scale of measurement, it is usually the place in which the population is centered. Numerically, it equals the sum of the scores divided by the number of scores. For example, the sum of 3, 7, 10, 15, and 25 is 60, thus, the mean is 60 divided by 5, or 12. The geometric mean is another type of mean. For two quantities, it is the square root of the quantities' product. The notation is for n quantities, and the geometric mean is the nth root of their product.
What is the origin of the word algebra?
The word algebra comes from the title of the book Al-Jabr w al-Muka Bala by Persian mathematician Muhammad ibn Musa al-Khwarizmi, 783 c. 850, also seen as Al-Khwarizmi or Al-Khwarizmi. The book is roughly translated as Transposition and Reduction, in which he explains the basics of algebraic methods. For more information about the history of algebra, see History of Mathematics.
What does the word parallel mean in geometry?
In geometry, parallel means two lines in two-dimensional Euclidean space that do not intersect, or two lines in the same plane that never meet and that maintain the same distance from each other at every point. In three-dimensional Euclidean space, these lines also do not intersect. maintaining a constant separation between points closest to each other on the two lines. In analytic geometry, parallel means those lines with the same slope, as well as other curves with the same slope for every x value. The symbol for parallel lines is. For example, AB means that line A is parallel to line B.
What is a cumulative distribution?
A cumulative distribution is a plot of the number of observations that fall in or below an interval. For example, they are often used to determine where scores fall in a standardized test. For example, the x-axis, see bar graph illustration on next page, shows the intervals of scores. Such as the interval labeled 35 shows any score from 32.5 to 37.5, and so on. And the y-axis shows the number of students scoring in or below each interval. This graphically illustrates for the students, and teachers, how well they did on the test compared to other students.
What is a microprocessor?
A microprocessor is a silicon chip that contains a CPU, or central processing unit, which is normally located on the main circuit board in a computer. In the world of personal computers, the terms microprocessor and CPU are often used interchangeably. These chips, or integrated circuits, are small, thin pieces of silicon onto which the transistors making up the microprocessor have been etched. The microprocessor is the heart of any normal computer, from desktops and laptop machines to a larger server. They have many uses. For example, they control the logic of almost all familiar digital devices, from microwaves and clock radios to fuel injection systems for automobiles.
Who were the Akkadians?
The region of Mesopotamia was once the center of the Sumerian civilization, a culture that flourished before 3500 BCE. Not only did the Sumerians have a counting and writing system, but they were also a progressive culture, supporting irrigation systems, a legal system, and even a crude postal service. By about 2300 BCE, the Akkadians invaded the area, emerging as the dominant culture. As most conquerors do, they imposed their own language on the area and even used the Sumerians' cuneiform system to spread their language and traditions, although the Akkadians brought a more backward culture into the mix. They were responsible for inventing the abacus, an ancient counting tool. By 2150 BCE, the Sumerians had had enough. They revolted against the Akkadian rule, eventually taking over again. However, the Sumerians did not maintain their independence for long. By 2000 BCE their empire had collapsed. undermined by attacks from the west by Amorites and from the east by Elamites. As the Sumerians disappeared, they were replaced by the Assyro-Babylonians, who eventually established their capital at Babylon.
What is arithmetic progression?
Arithmetic progression is one of the more simple types of series in mathematics. It is usually in the form of a and d, a plus 2d, a plus 3d, and so on, in which a is the first term and d is the constant difference between the two successive terms. A progression is also seen as these numbers are added, as in a plus, a and d, plus, a plus 2d, plus, a plus 3d, plus, a plus, n plus 1, d. An example of an arithmetic progression would be 2 plus 6 plus 10 plus 14 plus, in which d is equal to 4.
When was quantum mechanics developed?
There was not one major year in which quantum mechanics was developed, or even one major scientist who proposed the idea. This modern theory of physics evolved over about 30 years, with many scientists contributing to it. Beginning about 1900, Max Planck proposed that energies of any harmonic oscillator, such as the atoms of a black body radiator, are restricted to certain values. Mathematics came into play here, too, with each value an integral multiple of a basic, minimum value. Planck developed the equation E equals hv, or h times nu, in which E, the energy of the basic quantum, is directly proportional to the v, the frequency of the oscillator, multiplied by h, or Planck's constant, 6.63 x 10 to 34 joule-second. From there, mainly with the use of rigorous mathematics, others expanded or added to Planck's idea, including German scientist Albert Einstein, 1879 to 1955, who explained the photoelectric effect. New Zealand-born British physicist Ernest Rutherford, 1871 to 1937, and Danish physicist Niels Bohr, 1885 to 1962, who explained both atomic structure and spectra. Austrian physicist Erwin Schrödinger, 1887 to 1961, who developed wave mechanics, and German physicist Werner Karl Heisenberg, 1901 to 1976, who discovered the uncertainty principle. Out of these studies came quantum mechanics, in the 1920s, quantum statistics, and quantum field theory. Today, quantum mechanics and Einstein's theory of relativity form the foundation of modern physics. These theories continually change or are modified as we get closer to understanding more about the physics and mathematics of our universe.
What does iteration mean?
In most English texts, iteration means to repeat, and this holds true for mathematics. In the case of numbers, Iteration means a procedure in which the result is fed back and the procedure repeated. In some instances, it is repeated over and over. For example, to find the square root of 39. You can use iteration or repeat a procedure to find the solution. Knowing that the solution must be close to 6, or the square root of 36, a number close to 39. One can divide 39 by 6, 39 sixths, and get 6.5. Next, average 6 and 6.5 to get 6.25, then iterate again. Dividing 39 by 6.25, 39/6.25, equals 6.24, the actual square root of 39 is 6.244997. One of the most obvious instances in which iterations take place is in a calculator or computer. For example, in order to get the square root of 39, as in the example above, a calculator or computer automatically uses iteration to calculate the answer to a certain decimal place. The more numbers in a procedure, the more iterations are needed. Which is why supercomputing has become such a great asset not only to mathematics but many other sciences as well.
For what other invention was John Napier known?
Scottish mathematician John Napier may have been known for his contributions to logarithms. But he was also the inventor of a tool called Napier's bones, also known as Napier's rods. These were multiplication tables inscribed on strips of animal bone or wood. Wilhelm Schickard would eventually build the first calculating machine based on Napier's bones. A device that could add, subtract, and with help multiply or divide. Napier was also the instigator in another discovery, in 1621 English mathematician and clergyman William Oughtred. 1575 to 1660, used Napier's logarithms as the basis for the slide rule. A ruler-like instrument used long before handheld calculators came into vogue. Oughtred not only invented the standard rectilinear slide rule, but also the circular slide rule, which was an extremely useful tool that remained in common usage for more than 300 years. For more about Oughtred, see Math Basics.
What does an equal sign represent?
In standard arithmetic terms, the equal sign, smiley face, is a symbol that represents two amounts with the same value. For example, 7 equals 7, or 3 plus 4 equals 7. When something is not equal, the sign is asterisk. As in 2 asterisk 3 or 3 plus 7 asterisk 12. In a line of computer code, the equal sign can mean something much different. For example, for codes used under certain conditions, such as a JavaScript reading computer, a single equal sign in a line of script means is. There is even a double equal sign, equals, smiley face, that means is equal to. an important difference when writing code for the computer. In addition, and confusing as it may seem, the computer codes for not equal are different, and include equals and slash equals.
What is a polygon?
The word polygon means many angles, Greek poly for many, gonies for angle. It is a closed figure in a plane made up of line segments, straight with no curves, that intersect only at their vertices, endpoints. In other words, no sides, lines, can touch each other except at endpoints. A polygon has the same number of sides as it has vertices.
How is the Pythagorean theorem connected to right triangles?
The Pythagorean theorem deals with right triangles, simply stated. The sum of the squares of the legs equals the square of the hypotenuse, longest side. The converse of the Pythagorean theorem is also true, if the sum of the squares of a triangle's two sides equals the square of the longest side, then the triangle is a right triangle. For an illustration of the Pythagorean theorem, see History of Mathematics.
What were some highlights in the development of modern computers?
The first general-purpose analog computer was designed in 1930 by American scientist Vannevar Bush. 1890 to 1974, who built a mechanically operated device called a differential analyzer. The first semi-electronic digital computing device was built by mathematician and physicist John Vincent Atanasoff. 1903 to 1995, and one of his graduate students, Clifford E. Berry, 1918 to 1963, between 1937 and 1942. It was created primarily to solve large systems of simultaneous linear equations. It is interesting to note that Atanasoff's computer was overshadowed by the electronic numerical integrator and computer ENIAC, see below, which was once credited as the first computer. In 1973, however, a federal judge recognized Atanasoff's work and voided Sperry-Rand's patent on the ENIAC, saying it had been derived from Atanasoff's invention. Today, Atanasoff and Berry get the credit. The Harvard Mark I, or the automatic sequence-controlled calculator, was built between 1939 and 1944 by American computer scientist Howard H. Aiken, 1900 to 1973. And his team. It is thought of as the first large-scale automatic digital computer. But there are disagreements about this, with some historians believing that German engineer Konrad Zuse C3, see above, was the first such machine. Other early computers were the ENIAC 1 and the UNIVAC. The ENIAC, electronic numerical integrator and calculator, was completed in 1946 at the University of Pennsylvania. It used thousands of vacuum tubes. Until 1973. It was thought of as the first semi-electronic digital computer. That credit was subsequently given to Atanasoff and Berry, see above. The UNIVAC, Universal Automatic Computer, was built in 1951 and was the first computer to handle both numeric and alphabetic data. It also was the first commercially available computer. The third-generation integrated circuit machines were used primarily during the mid-1960s and 1970s, making the computers smaller, faster, close to 1 million operations per second, and far more reliable. The first commercial microprocessor was the Intel 4004, which appeared in 1971. It could only add and subtract, and it was used to power one of the first portable electronic calculators. The real push in microprocessors came during the late 1970s to 1990s, allowing for increasingly smaller and more powerful computers. For example, in 1974 the Intel 8080 processor had a clock speed of 2 MHz. By 2004 the Pentium 4, Prescott, had a clock speed of 3.6 GHz. Computers that use microprocessors include the personal computer and personal digital assistant, PDA. The computer industry has continued rapid growth, mainly thanks to the increased performance of advanced microprocessors.
How did some ancient cultures refine their calendars?
There were many different ways that various ancient cultures refined their calendars, and all of them entailed some type of mathematical calculation. One way to measure the length of a year was by using a gnomon, or a structure that casts a shadow. For more about gnomons and sundials, see p. 57. This was based on the apparent motion of the sun across the sky, with the shadow not only used to tell daily time but also to determine the summer solstice, when the shadow created by the gnomon would be at its shortest at noon. By measuring 2 successive summer solstices and counting the days in between. Various ancient cultures such as the Egyptians developed a more detailed calendar and, as a bonus, determined the exact times of the solstice. Around 135 BCE, Greek astronomer and mathematician Hipparchus of Rhodes, c. 170–c. 125 BCE, decided to compare his estimate of the vernal spring in the northern hemisphere, occurring in March, equinox with that made by another astronomer about 150 years earlier. By averaging the number of days, he estimated that a year was equal to 365.24667 days. A number only off by about 6 minutes and 16 seconds.
What is measurement?
Measurement refers to the methods used to determine length, volume, distance, mass, weight, or some other quantity or dimension. Each measurement is defined by specific units, such as inches and centimeters for length, or pounds and kilograms for weight. Such measurements are an integral part of our world, from their importance in travel and trade, to weather forecasting and engineering a bridge.
What do columns and rows mean when discussing vectors?
Vectors can be described by columns and rows. For example, two-dimensional and three-dimensional vectors are usually represented as a single vertical column of numeric values.
What is a linear equation?
As the term suggests, linear equations have to do with lines, and in algebra, a linear equation means certain equations, or functions, whose graph is a line. For an extensive explanation of graphs, see geometry and trigonometry. More specifically, in algebra, a linear equation is one that contains simply the variable, which makes them one of the simplest types of equations. For example, a linear equation in one variable has one unknown, the variable, represented by a letter. This letter, usually x, is always to the power of 1, meaning there is no x2 or x3 in the equation. For instance, x plus 3 equals 9 is a simple linear equation. To solve such an equation, one must either add, subtract, multiply, and slash or divide both sides of the equation by numbers and variables, and do this in the correct order to end up with a solution. A single variable and single number on opposite sides of the equals sign. In this case, the solution to the linear equation is x equals 6. Finally, linear equations can be further broken down. For example, in the linear equation x plus y plus cz plus dw equals h, in which a, b, c, and d are known numbers and x, y, z, and w are unknown numbers, if h equals 0, the linear equation is said to be homogeneous.
What is mathematical logic?
Mathematical logic is not the logic of mathematics, but is really the mathematics of logic, composed of those parts of logic that can be modeled mathematically. Overall, it was invented to understand and present the work of Austrian-American mathematician and logician Kurt Gödel. 1906 to 1978, and his interpretation of the foundations of mathematics in the early 20th century. Although mathematicians use mathematical logic to have rational and reasonable discussions of the many issues in the foundations of mathematics, not everything is agreed upon.
What is engineering?
Engineering is a discipline that deals with the art or science of applying scientific knowledge to solve practical problems, usually in the areas of commerce and industry. Scientists ask the why of a question, then research the answer. In contrast, engineers want to know how to solve the problem and then how to implement the solution. But it's not always easy to separate the two. Often a scientist has to use engineering basics, such as building special equipment for research. And engineers often have to do scientific research. The word engineer, as well as engine, developed from the Latin root ingenius, skilled. In some languages, such as Arabic, the word for engineering also means geometry. The various branches of engineering include aerospace, agriculture, architectural, biomedical, computer, civil, chemical, electrical, environmental, mechanical, petroleum, and material science.
How do you reduce a fraction?
To reduce a fraction, there are three general steps: factor the numerator, factor the denominator, and cancel out the fractional mixes that have the value of 1. The leftover number is the reduced fraction. For example, to reduce 16/56, the reduced fraction equals 2/7.
What is a tensor?
A tensor is a quantity that depends linearly on many vector variables. They are considered to be a set of n components that are functions of the coordinates at any point in n-dimensional space. Tensors are used in several fields of mathematics, such as the theory of elasticity, stress and strain, and mathematical physics, especially with regard to the theory of relativity.
How were mathematics and religion intertwined in ancient times?
One of the first references to religion and mathematics was around 4000 BCE, although this date is highly debated. Through the Vedic religion, which is followed by the Indo-Aryan peoples. Two works written in Vedic Sanskrit were the Vedas and Vedanas, both of which not only discuss religion, but also include a great deal of astronomical and mathematical knowledge throughout the text. Another connection between religion and mathematics grew through the practice of astrology, which is thought to have started around the 4th century BCE by the Babylonians. Astrology, the belief that celestial bodies control the affairs and fates of individuals, kings, and nations, was a kind of religion in ancient times. It was based on the position of the moon, planets, and constellations. In order to practice astrology, the astrologer needed an extraordinary knowledge not only of astronomy, but also of mathematics, including the use of algorithms to calculate some of the predictive results. Still another connection is the one between Christianity and math. Although it is often debated whether mathematics affected Christianity more or vice versa. What is known is that people who studied math and science in the past were often deeply entrenched in Christianity. For example, in the 16th and 17th centuries, great scientists such as Galileo Galilei, 1564 to 1642, Johannes Kepler, 1571 to 1630, Isaac Newton, 1643 to 1727, and Nicolaus Copernicus, 1473 to 1543. Were all deeply religious Christians who saw their scientific works as a religious undertaking. To actually list all the other connections between religion, science, and mathematics is far beyond the scope of this book. But as English physicist Freeman Dyson, 1923, once said, one of the basic connections came as the result of theological debate. And such arguments nurtured analytical thinking that could be applied to the analysis of natural phenomena.
What is a solar-based calendar?
A solar-based calendar is one based on the apparent movement of the Sun across the sky as we orbit around our star.
What is chemistry?
Chemistry is the science of matter. It studies the composition, structure, and properties of substances, matter, and its reactions and changes. Because chemistry includes all materials in the universe, it is useful for studying many things from the chemical composition of gases in galaxies to the chemical reactions within living cells. It also includes mathematics in many forms, such as when determining chemical compositions and understanding relationships between certain chemicals.
What is game theory?
As the words imply, game theory has to do with the mathematics and logic used in the analysis of games or the situations that involve groups with conflicting interests. Another way to look at a game is as a conflict that involves gains and losses between two or more opponents who all follow a set of formal rules. In particular, game theorists study the predicted and actual behavior of individuals in specific games, as well as the optimal strategies used in the games. Thus, the principles of game theory can be applied to games such as cards, checkers, and chess. Or, they can be applied to real-world problems in economics, politics, psychology, and even warfare. For example, game theory is used to determine optimal policy choices of presidential candidates, or even to analyze Major League Baseball salary negotiations.
What are the connections between logarithms and algebra?
Logarithms are the numbers of the power to which a base must be raised in order to get a given positive number. For example, the logarithm of 100 to the base 10 is 2, or log 10 100 equals 2. This is because 10 equals 100. Common logarithms are positive numbers that use the number 10 as the base. They are written as log x. Those using the number symbolized by e as the base are called natural logarithms. Also phrased as logarithms with a base e, the natural logarithm of a number x is written as ln x.
How do I make change?
Making change is an important monetary endeavor no matter where a person travels or lives. It is defined as the change, in coins and/or bills, a customer receives after making a purchase. Especially when the customer gives the merchant more money than the amount due. For example, say a person visiting a farmer's market in the United States buys a half pound of garlic for $2.60 and gives the merchant a $20 bill. To make change, the merchant would first subtract $20. $2.60 equals $17.40. Or the customer is to receive $17.40 in change. The resulting change would start with the highest denomination and work down, a $10 bill, a $5 bill, two $1 bills, a quarter, 25 cents, a dime, 10 cents, and a nickel, 5 cents. The merchant would then count the change out to the customer, stating each amount in the opposite fashion. That's a total of $2.60 out of $20, your change is $2.65. $2.65 as the nickel is given. $2.75. $2.75 as the dime is given, $3 as the quarter is given. $4 as the first dollar bill is given, $5 as the second dollar bill is given. $10 as the $5 bill is given, and 20 as the $10 bill is given.
What are the derivatives of trigonometric functions?
There are also derivatives of the 6 major trigonometric functions: sine, cosine, cotangent, cosecant, tangent, and secant. For more information on these trigonometric functions, see geometry and trigonometry.
What is a sample in statistics?
A sample is a generalization about a population and is represented by a group of units selected from the population, also called a subset of the population. The sample is meant to be representative of the population. Thus, in many studies, there are many possible samples. There are also types of samples, such as a matched sample, in which two of the members are paired. An example would be the IQ of twins. there is often a good reason for taking samples of a population. Most of the time, a population is too large to study as a whole. For example, take the smaller example of the above population of 10 cats. Again, none of them are identical, but certain common features between the cats can be measured, including color, fur length, and weight. If data is collected about the fur length of the 10 cats, the population, then if we chose only to take the cats with long fur, that would be a sampling. Another example is the population for a study of physical condition of all children born in the United States in the 1970s. The sample could be all children born on July 5 in any of those years.
What is a puzzle?
A puzzle is a mathematical problem that produces a solution often in the form of rearranging pieces, often geometric, or filling in the blanks, such as a crossword puzzle. Puzzles do not typically require superior mathematical knowledge, but many originate from more advanced mathematical or logistical problems. They also include board games, such as chess, and brain teasers.
What is the range of a set of numbers?
The range of a sample, or data set, is used to characterize the spread or dispersion among observations in a given population, as it is the distance between the highest and lowest numbers. In statistics, it is often, logically, referred to as the statistical range. Numerically, it is represented by the highest score minus the lowest score. For example, for the range of the numbers 34, 84, 48, 65, 92, and 22, the range is 92 22 equals 70.
How was math used to discover extrasolar planets?
Astronomers have always dreamed about detecting other planets outside our solar system, or extrasolar planets. In 1994, Polish astronomer Alexander Wolszczyn, 1946, announced the discovery of the first extrasolar planet actually. It was two planets with masses 3.4 and 2.8 times that of Earth's mass orbiting the pulsar PSRB 1257 plus 12. A pulsar star sends out a periodic pulse of light detected from Earth. Wolszczyn found the planets by measuring the periodic variation in the pulse arrival time. There are several major methods used to search for extrasolar planets, and all of them entail using mathematics. For example, the Doppler shift method measures the change in wavelength, color, of light coming from a star over the course of days, months, and years. The change in wavelength or the Doppler shift of the light is caused by the star orbiting a common center of mass with a companion planet. An example in our own solar system is the gas giant Jupiter. Its massive gravitational pull causes the Sun to wobble around a circle with a velocity of 39.4 feet, 12 meters, per second. Another detection method is called astrometry, which measures the periodic wobble that a planet causes in the position of its parent star. In this case, the minimum detectable planet mass gets smaller, in inverse proportion to the planet's distance from the star. These methods work, and by 2005 more than 150 such planets have been discovered.
What mathematical concept was featured in the movie The Andromeda Strain?
The concept of exponential growth, also known as geometric growth, provided the tension in this movie and the book on which it was based. The basic premise was that microscopic organisms had been inadvertently brought to Earth from outer space by a returning satellite. Once on Earth, they reproduced exponentially, doubling in number every 20 minutes. Very quickly, they spread over the entire planet, killing nearly everyone. And no, we won't give away the ending.
Who explained the nature of logarithms?
Scottish mathematician John Napier, 1550 to 1617, first conceived the idea of logarithms in 1594. It took him 20 years, until 1614, to publish a canon of logarithms called Mirifici Logarithmorum Canonis Descripto, description of the wonderful canon of logarithms. The canon explains the nature of logarithms, gives their rules of use, and offers logarithmic tables. For more about logarithms, see algebra.
Is a human's normal body temperature really 98.6 degrees Fahrenheit?
Although everyone seems to be taught that the normal human body temperature is 98.6 degrees Fahrenheit, in reality, normal has a range. In fact, a person's actual measured temperature is rarely exactly 98.6 degrees Fahrenheit. One reason for this has to do with how the old standard was calculated. Using an oral mercury thermometer and basing the results on a small human sampling. Gone are the days of putting a thermometer under one's tongue for 5 to 10 minutes. Today's thermometers are more sophisticated, accurate, and faster. Thus researchers believe that, based on better data and more people tested, normal body temperatures measured orally range from 97.5 to 98.8. With about 1 in 20 people having a bit higher or lower normal temperatures. These numbers change throughout the day, too, varying from 1 to 2 degrees, on the average. Reaching a low at about 2 a.m. to 4 a.m., and a high 12 hours later. An even more accurate representation of a body's temperature is to measure the core temperature. or the actual temperature inside the body, usually by using a rectal or inner ear, tympanic, thermometer.
What is a geometric sequence?
A geometric sequence or geometric progression is a finite or infinite sequence of real numbers with the ratio between two consecutive terms being constant, called the common ratio or R. In this case, each term is the previous term multiplied by a given number. In a geometric sequence, the formula for the nth term, in terms of the first number and the common ratio, becomes n equals a 1 r n1. Here the first term a 1, r is the common ratio, and the number of terms is n. For example, for the numbers 2, 6, 18, 54, 100, and 62, a 1 is 2, r is 3, and n is 5. The equation then becomes 2x 35 to 1 equals 162.
How does one interpret sets?
There are several ways to look at sets. Two sets, or more, are considered identical if, and only if, they have the same collection of objects or entities. This is a principle known as extensionality. For example, the set A, B, C is considered to be the same as set A, B, C. Of course, because the elements are the same, the set A, B, C and the set C, B, A are also the same, even though they are written in a different order. It becomes more complex when sets are elements of other sets. So it is important to note the position of the brackets. For example, the set A, B, C is distinct from the set A, B, C. Note that the brackets differ. In turn, the set A, B is an element of the set A, B, C. It is a set included between the outside brackets. Another example that shows how sets are interpreted includes the following. If B is the set of real numbers that are solutions of the equation x2 equals 9, then the set can be written as B equals x. x2 equals 9, or B is the set of all x such that x2 equals 9. Thus B is 3, minus 3.
How do you perform imaginary number computations?
Imaginary numbers come in handy to do many computations, especially something called simplification.
What was the Pythagorean society?
Greek philosopher and mathematician Pythagoras of Samos, c. 582 c. 507 BCE, not only contributed the Pythagorean theorem to mathematics, but also started a group, some say cult, called the Pythagorean Society. The school he founded stressed the necessity for people to be well-rounded and also taught reincarnation and mysticism, making it similar to or perhaps influenced by the earlier Orphic cult. The fundamental belief of the Pythagoreans was that all is number, or that the entire universe, even abstract ethical concepts like justice, could be explained in terms of numbers. In fact, Pythagoras was so enamored with the concept of numbers that his beliefs were centered around the premise that the entire universe was based on a mathematical algorithm. But the society also had some interesting non-mathematical beliefs, too. Those in the inner circle of the society were called the mathematikoi, the lived permanently with the other Pythagoreans, had no personal possessions, and were vegetarians. Those in the outer circle of the society were known as akosmatics. They lived in their own houses and only came to the society gatherings during the day. Even women were allowed to join, some of them becoming famous philosophers. Although Pythagoras is thought to have written many works, the secrecy of his school and its communalism has made it difficult to distinguish between the works of Pythagoras and those of his followers. For more information about Pythagoras and the Pythagoreans, see above and History of Mathematics.
What do plant hardiness zone numbers mean?
Plant hardiness zones are another way numbers are used. In this case, they indicate the average annual minimum temperatures for land masses around the world. For example, one common plant hardiness zone map is broken down into 20 different zones based on the average annual minimum temperatures. In Zone 5A, for example, the average annual minimum temperature ranges from -20 to -15 degrees Fahrenheit, -26.2 to -28.8 degrees centigrade, for example, Des Moines, Iowa. In Zone 11, such temperatures are above 40 degrees Fahrenheit, 4.5 degrees centigrade, for example, Honolulu, Hawaii. And in Zone 1, such temperatures are below -50 degrees Fahrenheit, -45.6 degrees centigrade, for example, Fairbanks, Alaska. There are other maps, too, that break down the zones into even more detail.
What was the main problem with the invention of zero by the Mayans?
Unlike more mobile cultures, they were not able to spread the word around the world. Thus, their claim as the first people to use the symbol for zero took centuries to uncover. For more information about zero, see Mathematics Throughout History.
What is the Monty Hall problem?
Let's Make a Deal, a once popular television game show with host Monty Hall, who was the master of ceremonies from 1963 to 1986, is the origin of the Monty Hall problem. The same type of problem is also represented in a card game called 3-Card Monte. The Monty Hall problem is similar to the show. A contestant is given a choice of 3 doors. Behind one is a car, behind the other 2 there is nothing. The host asks the contestant to pick a door. After the pick, the host opens one of the unpicked doors. One the host knows is empty. The host then suggests a switch. The big question, and the problem, becomes, does the contestant switch his or her choice or keep the originally chosen door? The mathematical, statistical answer is yes, switch the doors. Why? Because the original probability that the contestant picked the correct door does not change. It is still 1/3. But if the contestant does switch, the probability becomes 2/3. Most people believe that once one of the doors is eliminated, the probability between the remaining doors becomes 50-50, but it does not.
What is the degree of a polynomial equation?
The highest order power, or exponent, used in a univariate polynomial is called its polynomial degree or order. It is also defined as the largest, or maximum, sum of exponents that appear on the variables in the equation's terms. Commonly, the word degree is used more frequently because order has another meaning when discussing polynomials. You can also talk about degrees in reference to monomials, binomials, and trinomials. The degree of a monomial is the sum of the degrees of the variable in the equation. The degrees of the other polynomial equations are the greatest of the degrees in terms after the equation has been simplified. For example, a third-degree trinomial equation is x3 3x2 equals 0.
What are the various forms of calculus?
As mentioned above, calculus uses infinite processes that involve passage to a limit. In order to solve its functions, it includes a formal set of mathematical rules applied to changing quantities. Many mathematicians break down calculus into 2 branches. The first is integral calculus, or the general problems of measuring length, area, volume, and other quantities as limits. By approximating polygonal shapes, it finds the quantity when the rate of change is known. The second branch deals with discovering the tangent line to a curve at a specific point, or differential calculus. In this case, the calculus determines the quantity's rate of change. There also are several other forms of mathematical analysis that depend on calculus methods, such as vector analysis, tensor analysis, differential geometry, and complex variable analysis.
What is numerical analysis?
Numerical analysis is a branch of applied mathematics that studies certain specialized Techniques for solving mathematical problems. It employs mathematical axioms, theorems, and proofs, and often uses empirical results to further analyze or examine new methods.
What was the House of Wisdom?
Around 786, the fifth caliph of the Abbasid dynasty began with Caliph Harun al-Rashid, a leader who encouraged learning, including the translation of many major Greek treatises into Arabic, such as Euclid's Elements. Al-Ma'mun, 786 to 833, the next caliph, was even more interested in scholarship, creating the House of Wisdom in Baghdad, one of several scientific centers in the Islamic Empire. Here, too, Greek works such as Galen's medical writings and Ptolemy's astronomical treatises were translated. Not by language experts ignorant of mathematics, but by scientists and mathematicians such as Al-Kindi, 801 to 873. Muhammad ibn Musa al-Khwarizmi, see below, and the famous translator Hunan ibn Ishaq, 809 to 873.
A first-order differential equation takes the form. What is an example of a differential equation?
An example of a differential equation involves letting y be some function of the independent variable t.
Why was mathematics so important to the Greeks?
With a numbering system in place and knowledge from the Babylonians, the Greeks became masters of mathematics, with the most progress taking place between the years of 300 BCE and 200 CE. Although the Greek culture had been in existence long before that time, the Greeks changed the nature and approach to math, and they considered it one of the, if not the most important subjects in science. The main reason for their proclivity towards mathematics is easy to understand. The Greeks preferred reasoning over any other activity. Mathematics is based on reasoning. Unlike many scientific endeavors that require experimentation and observation,